This is a lesson on adding and subtracting polynomials. So first of all, you should know what a polynomial is, and you should be able to look at them and say the different parts, coefficients, degrees, bases, etc. So when we're looking at this first polynomial here, we have 5x squared plus 3x plus 10, and the second one is 7x minus 9x squared plus 13. And we're adding them. Now, since there's no multiplication or division, we can just look for like terms, and like terms are going to have the same base with exactly the same exponent. So I'll highlight the like terms here. So we have 5x squared is a like term with 9x squared. We have the positive 3x with the positive 7x, and we have the positive 10 and the positive 13. And all I'm going to do is add like terms together. So if I have 5x squared and negative 9x squared, I add those together and I get negative 4x squared. I have 3x plus 7x, which would give me a plus 10x. And then I have 10 plus 13, which is a positive 26. And that's the end of the problem. Pretty easy. Let's take a look at subtraction. Slightly different, but really basically the same sort of thing. So I'm going to look through this first polynomial for like terms in this polynomial. And let's pause for a second and let's make sure that we can really identify which ones are like terms. So let's look at 3x squared y. I need the same bases to the exact same exponent. So we're going to look through. Definitely not 7. 3xy is close, but the x doesn't have a squared. Negative 2x squared y does have exactly the same variables to the same exponents. So those two are like terms. And then we have 2xy squared. Looks pretty close, but notice that the x here and the x here is squared. And here, the x is to the first and the y is squared. So this is not a like term with these two. Looking at other like terms, I have a 9xy here, and I have a 3xy here. Again, looking at the exponents and the variables, we have an x and a y, each of them to the first power. So now we have no other like terms. So let's start with those. We're going to subtract 3x squared y minus a negative, so that's going to count as addition. So I'm really going to add 2x squared y to that, so that would give me 5x squared y. I also then have to subtract these. I have 9xy minus 3xy, which would give me a positive 6xy. I then have nothing to subtract the 10x with, so I'm just going to say that's going to stay the same. I'm really subtracting 0 from that. And then I have nothing to take away 2xy squared from, so it's 0 minus that. So 0 minus 2 would be a negative 2xy squared. And as far as the subtraction goes, we're done. And that looks pretty good. Last problem. Pretty similar. We're going to find like terms. 3 is a constant. Negative 8 is a constant. I'm going to do 3 minus a negative 8, which is 3 plus 8, or 11. X. Well, there's nothing in the second part that has an x, so I'm just going to drop it down. There's also nothing in the second part that has an x to the fifth, so I'm going to drop the negative 9x to the fifth down. And then we're going to subtract 0 minus 4x squared. And then 0 minus negative 8x cubed, which will change it to plus 8x cubed. Now there's a slightly different way to do each of these subtraction problems, and I'll just demonstrate with this last one. So another way to look at this problem, it's really like saying a -1 times this whole second set of parentheses. And if I want to distribute that, you can do that. Let's drop down the top, the first one. And then if I distribute that negative, it goes away and I get a plus. So I'm basically changing the second polynomial. I'm changing each of the signs. So -1 times -8 is +8. -1 times +4x squared is -4x squared. And then -1 times -8x cubed is a +8x cubed. And now I can just do addition. And now I have 3 plus 8, which is 11. I'm dropping down the x. I'm dropping down the -9x to the 5th. I'm going to now, since I have addition, 0 plus anything, I'm just going to drop down the -4x squared and the +8x cubed. And I end up with the same exact equation, or the same exact polynomial when I am done.